For several weeks, a MiG-29 fighter jet has been engaged in the mission of intercepting Ukrainian drones over the Black Sea, conducting low-altitude patrols from the Kacha airfield located in Crimea. The pilot of this aircraft has accumulated extensive experience through numerous interception sorties, relentlessly pursuing slow-moving reconnaissance UAVs and relaying precise coordinates to air defense units. Tonight, however, the jet is stationary in a concrete revetment, its engines cooled, and the pilot is asleep in quarters nearby. Meanwhile, 400 kilometers away, a weapon is already airborne, destined to ensure that this MiG-29 never takes flight again. Unbeknownst to the Russians, the attack is underway. At 0600 hours local time, a pneumatic catapult launched a UJ26 Beaver drone from a rail west of Croissant. The rear-mounted propeller instantly engaged, allowing the drone to ascend to 60 meters, level off, and enter cruise mode with quiet efficiency, so silent that a soldier standing 500 meters away would hear nothing but the wind. Meanwhile, 3 Ukrainian special operations soldiers had less than 2 minutes to retreat. They folded the launch rail in just 12 seconds, threw thermal blankets into their truck bed, and quickly exited the field via a dirt track adjacent to an irrigation canal. Meanwhile, the Beaver drone was already 2 kilometers downrange, climbing toward its cruise altitude. The targeted airfield, Kacha, was 398 kilometers southeast. However, the Russians were already on alert. Approximately 14 miles east, a Pol-21 electronic warfare tower detected an anomaly the moment the Beaver drone powered on. This system blankets the Nepo corridor with passive receivers tuned to recognize satellite navigation signals. The Beaver's encrypted GPS handshake sent a rapid frequency-hopping burst in the L-band, lasting only 4 milliseconds, yet it was enough to spike the noise floor on Russian sensors. A duty officer with Rubicon, Russia's specialized drone hunting unit, flagged the anomaly as a possible long-range UAV launch in progress, providing general coordinates in the Kherson sector. Minutes later, an Orlan 30 surveillance drone launched 6 kilometers east of the suspected launch point, its thermal camera scanning for any heat signatures indicative of a recently active vehicle. Looking at the Beaver drone as it climbs through 400 meters, one can understand why Rubicon prioritizes neutralizing the drone operators over merely shooting down drones. The drone's airframe measures 2.5 meters, constructed from fiberglass composite materials stretched over a canard configuration with small forward wings for pitch control, a swept main wing for lift, and a rear-mounted propeller that pushes it to speeds of 160 kilometers per hour. This composite construction results in an extremely low radar cross-section of just 0.01 to 0.03 square meters, smaller than most birds. At night, flying low over terrain clutter, the Beaver is essentially invisible to Russian air defense radars. However, the operators controlling these drones are not invisible. Rubicon understands that trained drone crews require months of rigorous preparation. These operators master radio frequency discipline, autonomous navigation management, and terminal guidance under extreme pressure. Eliminating these operators would cost Ukraine far more than losing a single drone. While the MiG-29 aircraft at Kacha can be replaced within weeks, the highly skilled men who launched this mission cannot be replaced so easily. The Orlan's FLIR thermal camera aboard the Orlan drone operates in the 3 to 5 micron infrared band, sensitive enough to detect the residual heat from a vehicle's engine that has been turned off for up to 20 minutes. Because heat decays at approximately 2 degrees Celsius per minute, the Ukrainian truck would remain visible to thermal sensors for another 15 to 20 minutes. Aware of this vulnerability, the Ukrainian team pulled into a collapsed barn, cut off their engine, and covered the hood with thermal blankets. For the next 8 minutes, they remained in absolute silence while the Orlan drone continued its search overhead. On the Orlan's thermal display, the fading heat signature of compressed grass where the vehicle's tires had rested flickered faintly. The operator vectored toward this anomaly, prompting Rubicon to dispatch 2 FPV hunter teams. The FPV drones carried by these teams are remarkably effective. Each aircraft weighs less than a kilogram, flies at speeds up to 120 kilometers per hour, and carries a fragmentation charge capable of destroying an engine block. The real advantage of the FPVs lies in their numbers. A single hunter team carries 6 to 8 FPV drones, enough to saturate a search sector and force the target to make mistakes. These drones fly at nap-of-the-earth altitudes of 10 to 15 meters, blending their small thermal signatures into the terrain clutter and maintaining an acoustic footprint below ambient noise until within 200 meters of their target. The FPV teams spread out along the two most likely exfiltration routes, a paved road north toward Kazan and a dirt track west toward abandoned farms. Russian doctrine assumes that drone operators will prioritize speed over concealment after launch, knowing that lingering near the launch site will almost certainly result in drone loss. However, the Ukrainian operators defied these assumptions. They did not take either of the expected routes, but instead remained hidden inside the barn, breathing shallowly, peering through a crack in the wall as an FPV drone passed 400 meters to the east. Meanwhile, the Beaver drone was now 50 kilometers downrange, climbing toward its cruise altitude of 800 meters. It would traverse the next 350 kilometers in complete silence, no uplink, no telemetry, no electronic emissions of any kind. The operators could not see where the drone was headed. They could not correct its course. They had to rely entirely on the navigation system to deliver the drone into Crimean airspace while focusing on their own survival. At 0616 hours, the Orlan drone passed directly over the barn. Its thermal camera registered the structure at ambient temperature. No vehicle, no personnel, no target. Rubicon logged the search as inconclusive and escalated to the next phase. The Beaver crossed the Dnepro River at 0635 hours, flying southeast toward Crimea along a heading that would take it over 200 kilometers of open steppe. No terrain masking, no cloud cover, just a composite airframe roughly the size of a dining table, cruising through radar coverage, extending 300 kilometers in every direction. Yet, Russian air defense detected almost nothing. The radar's interaction with the Beaver's airframe reveals why. Radar returns depend on the relationship between the radar wavelength, target size, and aspect angle. The Beaver's composite skin absorbs and scatters radar energy, rather than reflecting it back cleanly to the receiver. At grazing angles, when the radar beam hits the aircraft from below at a shallow angle, the return signal drops nearly to zero. Russian S-band search radars can theoretically detect a 0.03 square meter target at 40 to 50 kilometers, but only if the geometry is perfect. The Beaver's flight path was carefully calculated to avoid such geometries. The drone flew toward the Russian MiG on pure inertial navigation. Its GPS receiver remained active but did not transmit position updates back to the operators. The inertial navigation system tracks acceleration and rotation using gyroscopes and accelerometers, calculating the aircraft's position based on its starting point and movements, dead reckoning. This system drifts over time, accumulating errors of roughly 30 to 40 meters per minute without GPS correction. Over a 400-kilometer flight, this error would amount to less than a kilometer, close enough for the terminal phase where the operator can retake control. Back in the Rubicon Operations Center, analysts were running reverse vector reconstruction, RVR, applying mathematical techniques to plot radar detections backward to their likely launch origin. When a radar detects even a fleeting contact, the system logs bearing, altitude, and time. Plotting these detections on a map creates a track, and extending it backward projects a probability cone toward the source. The narrower the cone, the more precise the estimate. The Beaver had been detected twice, once by a Crimean early warning radar at 0641 hours, and again by a mobile S-300 acquisition radar at 0649. Neither detection lasted more than 2 seconds or produced a fire control solution, but together they provided a backward bearing pointing directly to the Cannes Orchard sector. Rubicon overlaid the RVR cone with terrain analysis, dirt road density, vegetation cover, historical strike patterns, and known Ukrainian staging areas. This analysis narrowed the probable launch corridor to a 20-kilometer stretch, exactly where the operators had launched. A second wave of Orlan 30 drones launched toward the suspected exfiltration routes, while FPV hunter teams repositioned to cover bridges and canal crossings. Somewhere within this corridor, 3 Ukrainians were hiding in a collapsed barn, waiting for the hunt to move on. The net tightened, yet the operators could not warn the drone, even if they wanted to, as any transmission would provide Rubicon with the precise information they needed. At 0700 hours, the Beaver's flight computer registered a GPS anomaly. The number of satellites detected dropped from 5 to 3, then flickered to 2. The navigation solution degraded from sub-meter accuracy to a 50-meter error circle that shifted erratically across the map. Russian electronic warfare had located the corridor. The ZTAL system, operating from truck-mounted platforms along likely UAV approach routes, broadcast GPS jamming signals in the L1 and L2 bands. These directional antennas created noise cones extending 30 to 50 kilometers, flooding GPS frequencies with noise to overwhelm the weak satellite signals. GPS satellites transmitted just 20 watts from 20,000 kilometers away, so even modest interference can drown out their signals. The ZTAL's effective range depends on terrain and atmospheric conditions, but can degrade navigation accuracy for any drone within 50 kilometers of the antenna. On this night, 3 ZTAL vehicles were positioned along the Crimean approach corridor, their coverage zones overlapping to form a continuous jamming blanket the Beaver could not avoid. The drone's flight computer switched to inertial navigation system only, INSO mode, and drift immediately began accumulating at approximately 35 meters per minute. Over the next hour, the drone would wander nearly a kilometer off its programmed course. While this error was still recoverable during terminal guidance, it required the operators to re-establish contact to correct the approach. Back at the barn, the Ukrainian team monitored their relay station's status panel. The Beaver was beyond direct radio range as it neared the Russian MiG, and the mid-course phase required complete emission silence. They had no way to correct navigation drift or even confirm the drone was still flying. They could only wait for the terminal phase and hope the drone arrived close enough for optical guidance to work. Meanwhile, Russian FPV hunter teams continued their search. At 0714 hours, an FPV drone passed within 400 meters of the barn. The operator watched its thermal camera feed sweep across the structure, pausing for 2 seconds before continuing east. The barn's collapsed roof created an irregular thermal profile that masked the truck hidden inside. The thermal blankets had cooled to ambient temperature, and the team held their breath. The FPV drone moved on. Rubicon was not attempting to shoot down the Beaver drone. Russian commanders understood that long-range composite drones routinely defeat short-range air defense systems. These drones have radar cross-sections too small to detect reliably. They fly at variable altitudes, and their approach vectors are unpredictable. Shooting down one drone means little if 10 more launch tomorrow. However, trained operators are irreplaceable. The months of discipline required to execute a mission like this, the silent launch, perfect exfiltration, and calm under pressure, cannot be mass-produced. Rubicon's entire doctrine centered on one calculation: eliminate the human operator, and the drone program collapses with them. At 0721 hours, the Ukrainian team restarted their truck. The engine had cooled enough to reduce its thermal signature below detection thresholds. They rolled out of the barn and turned south, away from the search pattern, heading toward a safe house 14 kilometers away. Meanwhile, the Beaver was now 180 kilometers from Kacha airfield. Terminal phase would begin in less than 40 minutes. At 0759 hours, the Beaver crossed into Crimean airspace, roughly 100 kilometers from the MiG. Its onboard computer activated the optical guidance camera and began transmitting a narrow beam uplink toward the relay station hidden in Ukraine-controlled territory. For the first time in 2 hours, the operators could see what the drone saw. The video feed was grainy and compressed for bandwidth, degraded by atmospheric interference, and jittery with a 120 millisecond latency that made fine corrections sluggish. But Kacha airfield was visible, a gray blur of runways and revetments gradually resolving as the Beaver descended toward attack altitude. The operator identified the target, a MiG-29 parked in a concrete shelter, its nose visible beyond blast walls. Rubicon detected the uplink instantly. Although the Beaver's terminal guidance system used a directional antenna to minimize detection, even a tightly focused beam produces side lobe leakage. stray radio frequency energy spilling outside the main transmission path. Russian signal arrays along the Crimean coast are calibrated to detect exactly this signature. Within 4 seconds, Rubicon obtained a bearing. Within 8 seconds, they triangulated the relay station's approximate position. This rapid detection and localization revealed the operator's position with a grid accuracy of 200 meters. The entire process from first detection to firing solution took just 11 seconds. By the time the Ukrainian operator completed his first steering correction, Rubicon already knew where to strike. The bearing pointed back toward Crescent, directly along the corridor where FPV teams had been searching for the past 2 hours. Rubicon unleashed everything. FPV drones along the bearing, a Lancet loitering munition aimed at the most probable vehicle route, and artillery fire coordinates sent to the nearest battery awaiting approval. The Ukrainian operators remained unaware, entirely focused on the camera feed showing the MiG-29 growing larger in frame. Due to latency, every input felt delayed, with the drone responding a heartbeat after commands were sent, forcing the operator to anticipate rather than react. At 08:05 hours, an artillery shell landed 2 kilometers behind the safe house, causing the team to freeze. The relay station's signal strength remained steady. The shell had missed the antenna. However, Rubicon had locked onto their coordinates, and more artillery was incoming. The operator forced himself to ignore the explosions and maintain focus on the screen. The Beaver was now 2 kilometers from its target, with only 90 seconds to impact. A second shell landed 1 kilometer east, and the team's security element reported 3 incoming FPV drones closing fast from the north. The operator checked the camera feed. The inertial navigation system drift, caused by the Zeetal jamming, had pushed the Beaver 340 meters left of its aim point. At its current heading, the drone would miss the revetment entirely and crash into an empty taxiway. The operator needed to send one correction, a 3-degree heading adjustment that would take less than 2 seconds to transmit. He sent the command and continued steering as the MiG-29 filled the camera frame with just 60 seconds remaining. As the Beaver commenced its terminal dive, the 3 Russian FPV drones screamed toward the transmission source at 140 kilometers per hour. On Rubicon's tactical display, the bearing lines converged on a bombed-out apartment complex 14 kilometers south of the original search area, exactly where triangulation had indicated the Ukrainian operators were broadcasting. The lead FPV dove at a 60-degree angle, locking its camera on a structure with a makeshift antenna array visible on the roof. The pilot did not hesitate. Speed mattered more than confirmation at this stage. The first FPV crashed into the antenna housing dead center, detonating its fragmentation charge, which shredded the transmitter array and collapsed the roof section onto the equipment below. Seconds later, the second FPV struck, punching through the damaged structure and exploding inside. The third impacted the north wall, ensuring complete destruction. Rubicon's tactical officer watched the feed turn white with each explosion. 3 direct hits, the transmission source obliterated. Artillery continued to fall around the coordinates for another 60 seconds, reducing the rubble to dust. Thermal imaging showed no movement or heat signatures. Rubicon logged the mission as a success. The Ukrainian drone team had been neutralized, or so Rubicon believed. The Beaver drone now flew without guidance, a dumb missile drifting on corrupted navigation, no longer a threat. But Rubicon made one critical assumption, that the operators were at the destroyed relay site. In reality, the 3-man team was a kilometer south, safely concealed inside a basement, with no antenna, no transmission equipment, and no detectable radio frequency signature. The relay had been remotely operated from the start, a deliberate sacrifice positioned separately because Rubicon would target any transmission source. The operators had never been within 500 meters of the destroyed equipment. Moreover, the final heading correction had already uploaded before the relay went dark. The Beaver's flight computer held the new course locked in memory, no longer requiring external input. The 3-degree heading adjustment pushed the MiG-29 back to center frame just before the relay went silent. At 08:06 hours and 34 seconds, the Beaver struck the MiG-29. The 20-kilogram KC-6 shaped charge detonated on impact, rupturing the fighter's aluminum skin from nose to tail. The cockpit disintegrated, aviation fuel sprayed across the concrete revetment, and ignited a half-second later, producing a fireball 40 meters into the Crimean sky. Secondary explosions reverberated through the airframe as ammunition cooked off and hydraulic lines ruptured. When the flames finally subsided, nothing remained but a blackened skeleton of titanium spars and melted wiring. The MiG-29 was destroyed. The Ukrainian mission was complete. The aircraft that had hunted drones relentlessly was no more. This operation vividly demonstrated the evolving nature of modern drone warfare, where stealthy, autonomous systems, combined with highly trained operators and sophisticated electronic warfare tactics, can strike deep into enemy airspace, neutralizing high-value targets with precision and minimal exposure. The complex interplay of drone technology, electronic warfare, and human skill underscores the challenges modern militaries face in both defending against and executing unmanned aerial operations. The Russian Rubicon unit's focus on eliminating operators rather than drones reflects an understanding of the human element's irreplaceable role in mission success. However, the Ukrainian team's strategic use of remote relay stations and careful emission discipline allowed them to outmaneuver even the most advanced detection and targeting systems. This battle over Crimea is a stark example of how asymmetric warfare and technological innovation continue to reshape the modern battlefield.